Hi. So code integrity powers guardrails for AI agents that are connected to tools. So the reason for this is now in enterprises, you're seeing a lot of AI agents that are using tools. It's very different from a generic chatbot because tools means now there's a exploit potential where in which tools can act as source and sinks and serve as conduits of malicious exploits. Our platform can red team and provide the expressive guardrails to detect these exploits. Here's an example of one we found in the Notion platform on the day they released Notion AI agents. The exploit was effectively through indirect prompt injection. Notion consumes a document that tricks the control flow of the agent into base64 encoding the contents of a Notion page and suffixing it to a web search or search to a malicious server. Um, when we talked to the Notion team, we were fascinated to know that the way they actually red teamed the exploit was red teamed their agent before actually deploying it was they kind of just manually sat in a room on a whiteboard, wrote a bunch of scenarios that could be bad, and just went through them sequentially. And unfortunately, they missed out on this web exploit. So how do we actually do this in an automated fashion? This is where we design the platform such that we're interested in solving for last mile security problems in AI agents that are operating in regulated spaces. All our customers at the moment, they're in highly regulated fintech exchanges or crypto exchanges or neobanks. And they've all deployed agents that are handling customer calls or doing confidential back office work. Um, Here's me replicating the Notion exploit of how our platform would have found it. So we're able to, through instrumentation, map all the tools of an AI agent into sources and sinks, then emulate toxic flow sequences where in which we can show that, okay, from this tool to this tool, there exists an exploit. And then with enough time, we're able to, through pass-through traffic, actually verify conclusively that that is an exploit. The way we guardrail it is our guardrails sit at 4 layers: input, output, tool output, pre and post. So there's a lot of touch points here. The idea here is you can write super expressive guardrails that are both stateless and stateful. So the stateless aspect could be PII detection, prompt injection and such. Stateful, where in which it's using heuristics to determine contiguous tool call sequences, non-contiguous tool call sequences, pull in external data. You can combine all of that data to write really powerful guardrails that solve this last mile problem. So the way we sell it is like it's 10% extra effort of work for exponentially more powerful guardrails. We have an SDK through which we can instrument LangChain, Claude, Google ADK. We can also sit as an MCP gateway, A2A gateway. We're tool agnostic. We don't really, it doesn't really matter what tool framework you're using as long as we can instrument it. We also work with any of the tool makers like Arcade, Composio, and such. Yeah, thanks.
All right. Thank you very